as we move into section 3 of chapter 7, looking at just a couple special rules, all of which are in your formula packet. So just always make sure that you're looking in there and you're familiar with what's in the formula packet. But we're looking at two special cases today, one for a function of e of x as well as the natural log of x. So, and again, derivatives on both these are in your formula packet. So real simple to start out with the first one. The derivative of e to the x is e to the x. So that's a nice simple one to work with. So here's a couple examples with some things that we've already done with the power rule, now involving e. So if you look at our first scenario here for part A, so if I have 2e to the x minus 6x to the 1/2, so remember you would format that like this before you did the power rule, but now you would just find the derivative of each term individually, as we've done in the past. So again, the derivative of e to the x is e to the x, so that first term is not going to change, but I will apply the power rule to this one. 1/2 times -6 gives me -3, and then subtract 1 from that exponent and you get this look here. And as I've said in some earlier videos, this is an okay format to leave your answer in unless the directions say otherwise. So that's always something you want to check, especially on a test. Same thing on this one. And again, feel free to pause the video at any time and try a couple as we move on down the line here. But we make sure that we format things in a friendly version like this one before you go ahead and start finding derivatives. But if I do each term individually, I got -2 times 5. And then if I subtract 1 from that power, I get this right here for my first term. Since the derivative of e to the x is e to the x, that term doesn't change. As you do this one, you're reminded of a rule right here that we're going to use within the next problem. But anytime you have a base of e and you raise that to a log of anything, anytime the base of your exponent, so remember I have a base right here of a natural log is automatically a base of e, and since this is the base of e, those automatically cancel each other out and I'm left with just x to the third. So that's just a rule that you got to be familiar with. So for the first term, if I just clean that up, I'm going to see that as just x to the third as my first term. So now I can go on down the line, do the power rule. Remember your constants go away when you do derivatives. So here would be the derivative of that function. So going on here into section 2, in the last lesson we did equations of tangent lines. And so we're still doing that now, but we're just applying these to the rules for e and natural logs. So anytime you want the equation of a tangent line, remember that tangent does not mean perpendicular. A lot of people make that mistake on our tests. Tangent is what they all are. They're all tangent lines. It's only if they throw in the word normal that you would do perpendicular. So in this case, in order to do the equation of a line, you need an x coordinate, a y coordinate, and a slope. So all we have to start with is an x coordinate. To get your y coordinate, you always plug this into the original function for x in order to get your y coordinate. So I'm going to replace that x with the natural log of 2. So here's what that would look like as you plug that in. So remember what I mentioned in the previous problem, because this has a base of e and this is a base of e, those cancel out and I'm just left with the 2. So I'm going to see this whole piece right here as 2 times -2. And so that's what this would look like if you were to clean that up. And I just get 4 for my y coordinate. So I now have an x coordinate, a y coordinate. All I need is a slope or a gradient. And you always get gradients by subbing in an x into the derivative. So if I find the derivative of this function doing what we just did up above, remember your constants go away. The derivative of e to the x is e to the x, so I'm just going to get -2e to the x as my derivative. And if I sub in my x coordinate into my derivative, I should get a slope out of that. So here we are subbing that in. Again, that's a base of natural log with a base of e. That's a base of e, and I'm left with just a 2 right there. So -2 times 2 is -4. So now you have your gradient or your slope of -4. And so here we go with our point slope setup. Again, you can either see it in this format or this format for point slope. Either way works. And again, just always check your directions on a test to see what format they want you to put your answer in. this is accepted unless the directions say otherwise. So moving on down, second rule. So we saw the e to the x derivative. Now you're getting the natural log derivative. The rule for the derivative of a natural log of anything is just 1 over that item. So, and again, this is in your formula packet, so you would have this rule on a test. But that's all it is. So the derivative of natural log of anything is 1 over that item. So as we look at something like this, so if we just said, so ignore the 14 for just a minute. If we said, what's the derivative of the natural log of x? That is 1 over x. So now if I did that times 14, I get this as my derivative. Same thing in a case like this. Remember, whenever you separate terms with a plus or a minus, you just do each term individually. So for the first part that I see here, so again, we know the natural log of x is 1 over x times 3. So that's what's going to help me with my first term. On the second term, I want to see this as x to the 1/3 power. So here's how we would format that so that I can use the power rule. So now if I did 1/3 times 24 and then subtract 1 from my exponent, that's going to help me get my second term, which would look like this. And then again, you could leave your answer like this unless the directions say otherwise, so this would be another format for that answer. Again, if you want to give this one a try on your own, this is a little more of the same type of thing. Again, you're just going to do each term individually. You do have another rule at work here. If I have the log with a base of something that is the same as this. So remember, there's automatically a base of e right here. So I got natural log base of e to this power. That rule would tell you to eliminate all this information, and I'm just left with 2x squared for that. So this first term is 2x squared. My second term is negative 5x squared. Now that I've put things into a friendlier format, now I can use the power rule to get a derivative. For this one, because these are both x squares, we could just combine like terms first, then do the power rule to get the derivative. That's probably the easiest approach on that one. For number 2, again, just doing another equation of a tangent line, applying our new rules here. So we have our function, 3 times the natural log of x. This is the x coordinate. So remember, we're going to need a y coordinate and a slope to get the equation of our line. So if the x coordinate is e squared, I'm going to take that and plug it into the original function right there for x in order to get a y coordinate. And so that's what you're seeing right here in this setup. So if I replace x with e squared, I get this look here. Because this is a base of e and this is an e, all I get out of this part of it is the exponent, which is just 2. So I'm looking at 3 times 2, which is my y coordinate. So now I have an x coordinate, a y coordinate. To finish it off and get my slope, I need to sub in my x value into the derivative. So if I take the derivative of this function, so remember the derivative of natural log of x is just 1 over x times 3. And so that's going to give you this look here. So we have our derivative, and if I sub in e squared in for x, then 3 over e squared is my slope. And so now I have enough information to go through with a point slope process. So you got your points right here for x1, y1, you got your slope, and if you could, again, you can leave it like this unless the directions say otherwise. If they did say otherwise, you would either cross multiply at this point, unless you started in this format, and then again from here you can rearrange things depending on what the directions ask you to do. For part C here, so getting down to the end, for part C, the first thing is asking me to find a result when I plug in a 4 into the first derivative. So I can get an exact answer on that. I can get that to 3 sig figs. So to start things off here, if I start by just finding the derivative, so using our power rule, we're looking at 3x squared minus 4e to the x as our derivative. This is asking me to sub in a 4 for x into that derivative. So if I replace this x with a 4 and this x with a 4, I'm going to get this look right here. This would be my answer in exact form. If I put this into a calculator, I'm going to get an irrational decimal because that's what e is. And so this would be as far as you could go by getting an exact answer. But if I did sub that into my calculator and round it off to 3 sig figs, we're going to get something like this, although that would not be 3 sig figs. That would only be 2 sig figs. that trailing 0 does not count as a sig fig. Exact same thing on this, so good place to pause if you want to give this next one a try. But again, you're going to find the derivative. You're going to sub in a 3 into that derivative. So moving into that, derivative of my first term would be 8x to the first. Right here I'm looking at negative 2 times 1 over x. And so here's what we end up with for our derivative. And if you plug a 3 in there, obviously you're going to get 24 on the first term, negative 2 over 3 on the second term. So this is what you're going to get as your exact answer if you take that as far as it could go. But if you plug that into your calculator and round it off to 3 sig figs, you're going to get that look here. For the last example, again, you got to key on the word normal here. So if you see that on a test, like right away, I would circle that or something, make it stand out to you, so you know to use a perpendicular slope when you go through this. So looking for the equation of the line, again, you need a point and a slope. All we have to start with is an x coordinate. So if I plug my x coordinate into the original function right here, then I'm going to get my y coordinate out of that. And so that's what you're seeing right here in the first part. So replaced x with e squared. And again, base of e eliminates each other, and I just get a 2 out of that. So I'm looking at 2 plus 3, which is 5. So I now have a y coordinate. All I need is a slope. So if I sub in this guy into my derivative, I'm going to get a slope. So if I find the derivative of this function, my constant goes away. Derivative of natural log of x is 1 over x. So here is our derivative, and I sub in e squared to get this. Since I have the word normal, I need the opposite reciprocal slope, which would be negative e squared. So I now have my slope. We have a point, and we can sub into point slope. And again, here this tends to be the more common approach for point slope. So here's the y coordinate, here's your slope, here's your x coordinate. But again, you could format it this way as well. Either way is accepted. And again, here's the very last one, kind of more of the same, using the new rules. So for this one, if x is 1, I can sub in a 1 right here for x to get my y coordinate. So 2e to the first is my y coordinate. And if I find the derivative of 2e to the x, which is 2e to the x, I can sub in a 1 right here, and I get 2e from my slope. Again, because this specifically said the normal, I have to do the opposite reciprocal slope of this guy, which would look like this. And again, now you can follow through with your point slope process. So here's your slope. Your point was positive 1, positive 2e. Or that was our point. Now I could clean that up to get any other look or any other format that we need from there.